Hello, everyone. Today we're going to start our deep dive into the mechanisms of reduction and oxidation. So we're going to start off with lithiol, my favorite reducing agent. It's very strong, very aggressive. If you leave it alone with your carbonyls, it's going to rip them all apart. It's kind of like a tiger in a cage. So let's go on and get to it as well. Lithiol could also be used for a lot of things, actually. It could also be used as a nucleophile, right? It could also open up rings as well, if you remember kind of how epoxides work. So we're gonna go over like some very like base situations, right? Of aldehydes, ketones, or carboxylic acids interacting with lithiol. So we'll go ahead and we will kind of go through that right now. And remember, right, the H's that are on lithiol, right, are hydrides. These are nucleophilic H's, right, that can go and do nucleophilic things. And so that's exactly what we're going to do here. So in the first case, right, aldehyde, it's going to go and attack onto here, and it's going to push this up onto here. And the resulting next step is going to be something along the lines of this. Yep. Then from there, right, you're going to have an H that came, a hydride that came from there. And then eventually, right, you can just do a quick proton transfer, or I believe maybe they might turn, I've heard people use the term aqueous workup too. And eventually you'll get an H kind of from another thing that's kind of floating around through here as well. Right? Very similar, very similar mechanism in the next one as well, right? This is a ketone, right? Very similar vibe. We tack onto here, this pops off onto here, and then eventually, right, you go over here and you will end up with this right here, right? Then you're going to end up with a oxygen that has something along the lines of here. It's going to go through a proton transfer, and then you're going to end up with, that was a really wacky, really wacky double arrow. You're going to end up with something along the lines of this. Yep. And so almost like the mechanism is basically like the exact same thing. It's just that with different end results, right? We have a primary alcohol here, right? Because of just the nature of having an aldehyde, right? And we have a secondary alcohol over here. Okay. And now the real kicker is when we have to go do things with when we have to go through things with carboxylic acids. And so yeah, let me go ahead and quickly find that real quick. Oh my God, I lost it. Where'd it go? Where'd it go? I apologize, guys. I don't know, like my notes got flipped overrun. And so, uh, gosh. Oh, yes, here we go. Sorry, I got mixed up around here. But yeah, carboxylic acids. Let's go on with those. So the first thing that what's going to happen here, right, is that one of these aldehydes is actually going to go and run away with one of these hydrogens that are right here on the carboxylic acid. And so the resulting step is that you are going to end up, right, with H kind of H2, right? Hydrogen kind of bubbling away. It's an irreversible arrow because you can't reverse this because how are we going to get hydrogen to come back into liquid form, right? Really crazy. And so from here, right, um, the from here you will have an aluminum that's going to have some empty orbitals. Empty orbitals. And here, empty orbitals. And then from there, right, you are going to get your, oops, I should probably move the other side to make it easier to attack, right? This is the carboxylic acid that whose hydrogen you just stole. Going to go in here, going to go into an attack, right? And then in a step that is more favored towards this way than that way, right? You are going to end up with, you're going to end up with an aluminum, right? That has this, and it's going to be attaching itself onto the carboxylic acid. Alrighty. And then from here, right, it's going to move One of these other hydrides is going to move in, attack, rip off what it can. This is going to pop off onto here, right? And this is going to be a very, very common pattern you'll see, right? A hydride will attack, right? It'll force a double bond, the electrons in the double bond, C double bond O, to pop up onto the oxygen itself, making it charged. And from here, right, in an irreversible step, you are going to make one of these bad boys. Bear with me here as I go kind of slow to make sure that I'm not making any super, super crazy mistakes, although I have caught myself in the past, so I sincerely apologize for that. All right. And so this H will be right here, right? And then from here, right, in a move I call the superhero landing, right? The electrons will come back down and slam this oxygen off onto its own, right? And then I'm probably gonna make give myself a little bit more space here. I totally underestimate space there. And then going on from here, you are going to end up with an aldehyde, right? An aldehyde on its own. Yep, aldehyde on its own. And then your aluminum and friends is going to be up here with a stolen oxygen. And it's kind of just going to be kind of chilling there. H. Mm-hmm. And then basically the same process repeats again. We have open orbitals here, and aldehyde is a lot more reactive than carboxylic acid. So it's going to go attack here, and then it's going to go and, oof, maybe I should try to figure out which direction will give me more space. If you ever see me in my actual SI or instruction sessions, uh, I run out of space very, very frequently. So I'm pretty sure a lot of people are having a laugh at me right now. So, yep. And you'll end up all the way. What was the best way to draw this? Okay, we'll draw it this way. And you're going to end up with this bad boy right here, right? Yes. Okay, cool. Just gotta stop to make sure I'm not screwing things up. And then from here, right, one of these other aluminum hydrides is going to go in, attack once more. It's going to push these onto here. You're going to end up with this bad boy right here. This time you don't really have a charge because oxygen is pretty chill, happy as a clam, with having one bond onto it, right? And so, oh yeah, we're gonna have I forgot a charge right here. Yep. Yep. And then from here, in this step, right? You don't really have to know the mechanism for this, right? But going from here to our final step, right? We have NaOH, right? H2O. You throw that in there, mix it around, and then eventually you will end up with your primary alcohol here. Yep. That was quite a long ways to go, but essentially, yep, you end up with that. Alrighty. So that was just one of our two strongest reducing agents. Luckily, right, sodium borohydrate is a little bit more simpler. So let me triple check and make sure I didn't miss anything here. Don't believe I did. Alrighty. So with that being said, right, we're going to go to the next one over here, right? So NABH4, right? Really, really weak reducing agent here. And so you're basically going to have like very, very similar reactions here, right? You have here, this pops off onto here, right? You could probably honestly just do these without waiting for me because I kind of go a little slow here. But let's see. Do. Have a red here, and then yep. Then you'll end up with something along the lines of this.